part 3 of our solving trig equations. Notice in this problem that we have something new again. In this problem, we are looking at a quadratic. Yes, that means that we are looking at this as a problem that we need to solve by either factoring, completing the square, or the quadratic formula. Now, I will tell you that factoring is probably going to be our best bet when dealing with trig equations. But some of us still have a hard time recognizing how on earth, they have a hard time factoring anyway, but how on earth am I supposed to factor this? So I'm going to come over to the side, and for just a second, I'm going to say x equals cosine theta. I'm going to substitute x everywhere there's a cosine theta in this problem. And I'm going to write 2x squared, because there was a cosine squared theta, minus x minus 1 equals 0. And we're going to factor that problem. And so we just now do normal standard factoring. You can use the Punnett square. You can use whatever method works for you. But I need you to know that 2x plus 1 times x minus 1 is the factor of 2x squared minus x minus 1. You can come see me about factoring that if you're not sure where that came from. Now, when you factor, you would say 2x plus 1 equals 0 and x minus 1 equals 0. So 2x equals negative 1. I just moved the 1 over. X equals negative 1/2. We're done there. X equals 1. Well, I did all the factoring and solving, but I still haven't dealt with the fact that x is cosine of theta. So I'm going to come back over here and I'm going to write that as cosine of theta equals negative 1/2, and cosine of theta from this one equals 1. And ask yourself, where on the unit circle is the cosine of theta equal to a negative 1/2? And we know that that happens when theta is equal to 2 pi over 3 and 4 pi over 3. Look on your unit circle, find the cosine value is negative 1/2. It happens in both of these locations, quadrant 2 and quadrant 3. Then ask yourself, where is the cosine value equal to 1? And that happens at 0 and at 2 pi, which is the same location, but remember, in our restrictions, 2 pi is not allowed. So our answers are theta is equal to 2 pi over 3, 4 pi over 3, and 0. All three of those answers would make this a true problem, a true statement. Okay, so let's look at 6b. Once again, we need to factor it, only now I'm going to come in and state that x equals sine of theta, because there's sine of thetas in all the problems. And I'm going to rewrite the problem as 2x squared minus 3x plus 1 equals 0. And we're going to factor that out. And if you're not sure how to factor it, come and see me. But I need you to know that 2x minus 1 times x minus 1 is the factor of this problem. And we've got 2x minus 1 equals 0. So 2x equals 1. X equals 1/2. X minus 1 equals 0. And so x equals 1. And now when we come back over here and write our answers, it's sine of theta equals positive 1/2. And sine of theta equals 1. Well, where on the unit circle does the sine of theta equal positive 1/2? That's going to be in quadrants 1 and 2, and that's going to happen at pi over 6 and 5 pi over 6, quadrants 1 and 2. Where is the sine value positive 1? Well, that happens at the top of your unit circle at pi over 2. And so the answer to the problem is pi over 6, 5 pi over 6, and pi over 2. Now, these last three problems are different still. These are the most complicated, not the hardest. They're not too hard to do, but they are the most complicated, because I want you to look at this. First of all, this problem has sine squared in it, so that's a quadratic with a single sine, but there's also a cosine squared. We cannot solve a problem that has two functions in it unless we do some changing. So remember those Pythagorean identities that we had earlier in the unit? the Pythagorean identities that we talked about, you have to remember that sine squared theta plus cosine squared theta is equal to 1. And what that means is if I wanted to get rid of one of these, and I'm going to probably choose to get rid of this because there's two of them that have sine in it, I have to isolate cosine theta. And how would I do that? By subtracting sine squared theta from both sides. And that cancels, that becomes 0, and I would get cosine squared theta equals 1 minus sine squared theta. Well, now I can replace this with 1 minus sine squared theta. Now the rest of the problem stays the same. It's still sine squared theta minus sine of theta equals 1 minus sine squared theta. Now, how do you solve an equation? Get everything on one side. That's going to give, I'm going to add sine squared of theta to both sides. That's going to give me 2 sine squared theta minus sine of theta. I'm going to subtract the 1 from both sides. Minus 1 equals 0. So 2 sine squared theta minus sine of theta minus 1 equals 0. Now look up at the problem we did before. Except for the fact that the word is cosine instead of sine, it's the exact same problem, which means that the factors are going to be the same. Sine of theta equals negative 1/2 and sine of theta equals 1. So I factored this problem just like before. I solved, I replaced back in with sine of theta, and tell me where that happens. Well, that happens in quadrants 3 and 4. So that's going to be at 7 pi over 6 and 11 pi over 6. Now I know we talked about a negative answer for inverse sine, but notice this problem doesn't have inverse sine written in it. We used inverse sine to solve it, but it doesn't have it written. So they want the positive answer, the one that's between 0 and 2 pi. And where does the sine value equal 1? At pi over 2. So my answers are 7 pi over 6, 11 pi over 6, and pi over 2. One more problem for an example. I've got cosine theta and sine squared theta. Now I can't have two functions, and I already know that sine theta, sine squared theta, can be replaced with 1 minus cosine squared theta. So I've got 3 cosine theta plus 3 equals 2 parentheses 1 minus cosine squared theta. Once again, to solve it, I need everything on the same side, but first I have to distribute that 2. I'm going to have 3 cosine of theta plus 3 equals 2 minus 2 cosine squared theta. I'm going to move everything to the left. Moving everything over, that's adding 2 cosine squared theta makes it positive. Plus 3 cosine theta. I'm going to subtract 2 from both sides, makes that plus 1 equals 0. Do you notice that this problem now and this problem are almost identical? The only difference is the plus sign there. The minus sign there, and now it's a plus sign. So this one's going to factor as 2x plus 1 and x plus 1. So I'm going to go ahead and write that out since it's a little different. 2x squared plus 3x plus 1 factors to 2x plus 1 times x plus 1. We set 2x plus 1 equal to 0 and x plus 1 equals to 0. So 2x equals negative 1/2 and x equals negative 1. Now, using that, I've got, x equals negative 1/2, not 2x. X equals negative 1/2. I've got cosine of theta equals negative 1/2 and cosine of theta equals negative 1. Well, cosine equals negative 1 at pi and cosine equals negative 1/2 at 2 pi over 3 and 4 pi over 3. Good luck. Have fun doing your homework.